Hi everyone, sorry it did cut me off. I asked for the extra limit, but I'm sure it's not going to come through in the evening. So let's look at this last one. So I have a compound that has a composition of 15.58% carbon, 3.9% hydrogen, and 18.18% nitrogen, and 63.34% oxygen. Once again, how you would get those is that would mean like percent composition that we just learned. That's how you'd get those numbers. And we're basically just working reverse. So what's its empirical formula? If its molar mass is 1,155 grams, what's the molecular formula? So let's take our different elements. So I have carbon, hydrogen, nitrogen, and oxygen. Okay. Once again, I'm going to take the percentages. So 15.58% is going to become 15.58 grams. So we're going to pretend that it is out of 100 grams. Make our life easy. 3.9 grams, 18.18 grams, and 63.34 grams. Now, you do not need to use this chart, for example, if you want to solve the problems. You could just write them out however you want. You do need to follow these steps, otherwise it's much harder to get the right answer if you're not following them. Of course, you feel free that you could take this and just copy and paste this empty chart and use it for any problems you wanted to. Whatever works for you, honestly. And you could just do it in the computer and type it in like I'm doing it. You could handwrite it. As long as for the quiz, you make sure to show me some work, okay? Okay, so back to this. So carbon, it has a mass of 12 grams in the periodic table. Hydrogen has 1 gram. Nitrogen has 14 grams. And oxygen has 16 grams. Okay, so 15.58 divided by 12 is going to give me 1.298. And that's my number of moles. This one, I hope you can all do mental math and divide by 1. Okay, 18.18 divided by 14 is 1.3 because it's 1.29857. You can write all that out if you want to. Just I'm not going past 3 decimal points because it's usually not worth it. So 1.3. Oops. And 63.34 divided by 16 equals 3.959. Okay. Our smallest one here is this one. Realistically, you could use the 1.3 and it would not make a difference. Because remember, we're going to round. So 1.298, 1.298, 1.298, and 1.298. And the reason we're going to 3 decimal points when we do this is, frankly, some people struggle with rounding, and 1.291 and 1.298 can give you a very different answer depending what some of the other ones are. So just that's why we go to 3 decimal points. Okay, so this is going to equal 1. This is going to come out to like 1.00 something, so we're going to call it 1. 3.9 divided by 1.298 is going to give us 3 when we round it. And 63 sorry, I'm back too far. 3.959 divided by 1.298 is going to give me roughly 3 as well. We don't need to make an adjustment. That's rare that you will need to. I just like to tell you have it there if it helps you guys to use this chart. So we're going to have C1, so we don't write the 1, H3, N1O3. Okay, remember molecular formula, we add up our empirical formulas first. So if I have, so carbon is 12, hydrogen I have 3 times 1, nitrogen I have 14, and oxygen I have 3 times 16. And if that messes you up, you can do it all as addition. You could, so we're going to add that up, and we're going to have 77 grams. Okay. We're going to do 1,155 divided by 77. And that's going to give us 15. So what we're going to do is multiply each thing by 15. So we're going to have C 15, H 45, N 15, O 45. Okay. Hope this helped. Enjoy your day.